Okay, here we go. We're going to look at some regression. This is our last topic, polynomial functions. So here's your handout, linear and quadratic regression. We're reviewing linear and quadratic regression, it says. I know we actually haven't done it before, so all of this is new. So we're going to start with linear regression. Number one is about linear regression. Linear means it's going to create a straight line. It's going to be a linear function. So with our graphing calculators, we are on the home screen right now, you can see, and we're going to go to the spreadsheet. Okay, so from this spreadsheet, we're going to enter the information that's already in the table here of information from our question. So we're looking at number one. The data below shows the average student loan debt accumulated by college graduates during certain years since 1969. Write an equation for the line of best fit and then estimate the average student loan debt for a student graduating in 2020. Okay, so first thing we're going to do, instead of using 1996, 2000, 2004, and so on, we're going to set the first year. Okay, so we're going to call this year, and the very first year we're going to call year 0. So therefore we need to figure out, okay, what year are all these other years? So 4 years later is 2000, so that'll be 4. 4 years later will be 8, sorry for the table shaking. 4 years later will be 12, and 1 year later will be 13. So these are the numbers we're actually going to use because this will be easier to interpret the equation. All right, so here we go. We're in the very top of our spreadsheet here in column A. We need to call it something, so we're going to call it year. So Y-E-A-R. You could choose whatever you want to call it. You can just use one letter if you wish, but I'm going to call mine year. All right, now you can see that I already populated this. So I have 0, 4, 8, 12, 13. You just 0, enter, 4, enter, 8, enter, 12, enter, 13, enter. Now we're going to go back up to the top of the next column. I'm going to put the loan debt at that time. I'm going to call it debt, D-E-B-T. Enter. Okay, and you can see I already entered this, but I'll pretend I'm re-entering it, making sure that 0 is with the 12,750. So enter, and that takes us down to the 4 and 17,350, and so on. Okay, just double check as you go back up to make sure you entered everything properly. All right, we're going to come over here to the first white cell of the next column that's empty. And here are the keystrokes that we're going to use. We're going to use menu, and we're looking at statistics here. So number 4 is statistics. Stat calculations, which is number 1. And this is linear regression. We've got 2 choices here for linear regression, depending on whether you like it in this form, y equals mx plus b, or whether you like this form, y equals a plus bx. In this form, m will be your slope and b your y-intercept. In this form, b will be your slope and a will be your y-intercept. I think most of us are more used to using this, so I'll choose that one. So number 3. All right, now our X list, our X inputs, okay? We called that year, so we're going to write year here. And what did we call our Y list? We called it debt, so D-E-B-T. And this rest of this is just going to tell us where our results will come up on the spreadsheet. We go down to OK and click OK. All right, so here's our results. It's telling us it's linear regression. The title, linear regression. The regression equation is in the form mx plus b, where m is equal to 830.285. So y equals mx plus b. M is 830.285. 0.285 x plus, and b, the y-intercept, is 13,045.8, but if you look at the little number that's hovering there, it would be rounded to 0.9. So this question didn't say to what point start rounding, so I'm going to keep as many digits as I can here. All right, so that's our regression equation. Y equals 830.285x plus 13,045.9, and where x represents the year after 1996, and y represents the debt owing at that year. Okay, so the question is then saying, then estimate the average student loan debt for a student graduating in 2020. Okay, so we're just going to use the equation that we came up with. We're going to go to our calculator. So from our home screen, just go to the calculator, either by scrolling up or selecting A for calculate. And we're going to do this. I'm just gonna get rid of my history here. So clear the history. Okay, so my scratch pad is empty. Just makes it a little easier for you to see what I'm doing. Okay, so what we're doing is we're going to figure out what year after 1996 is 2020, and we're going to plug it in there. So after 2020, so the year 2000 was 4 years after 1996. 2020 is 20 more years, so that's going to be 24. All right, so 830.285 times 24 plus 13,045.9, and that is 32,972.74. Now, let's take a look at these. They're rounded probably either to the nearest 10 or even the nearest 100. So we'll stay consistent with that with our answer. So let's say 32,970 as our answer. Okay, so we've answered that with linear regression. Now, so in the next question, we're going to do the same thing using our spreadsheet, okay, but it's telling us it's a quadratic model. All right, so and when we go there, we're going to enter all the data again. I'm not going to do that for you. You'll do it exactly the same as we did for the linear regression. But when you come here to use your menu, statistics, stat calculations, there are other opportunities. There's other kinds of regressions here. 3 and 4 are linear regression, but number 6 is quadratic regression. So that's the one you will use for number 2. Number 7 is cubic regression, and that's what you'll use for number 3. And so on the other page here. We've got a quartic regression. So we've got a quartic regression here, number 8. And then back here, back to cubic for number 5, and back to quartic for number 6. Okay, so that should help you complete your regression work.